Hey guys, so in this video I'm going to discuss question 6 of exercise 17.3 of Sitzer-Hammond, and the chapter is multivariable optimization. So in the previous video I discussed question 4 and I'm going to move ahead and discuss question 6, and I'm going to skip question 5. The reason behind skipping question 5 is that it becomes too complicated to solve it using extreme value theorem, and if you encounter that problem in exam, it is very much easier to solve it using Lagrange. Lagrange is something that I'll be introducing in my videos when I move on and go to chapter 18, which is constrained optimization, right? So I'll be discussing and taking up that question in that series of videos, right? So let's just start now. So question 6 says that question 6 So I'll be discussing question 5 later, right? So let's move on to question 6 now. So question 6 says that question 6 says that question 6 says that hell is my exercise. Consider the function f defined for all x comma y by, so my function fx comma y is let me zoom. So fx comma y is 3x square plus y square to the power 3 by 2 minus 4x square plus y square to the power 1 by 2 plus y. Right. So this is the function that has been given to us. Now we need to find the stationary points. Part A says that find stationary points of f of fx comma y. Also, they have written a very important statement. This question is very easy, but due to this single statement, if this single statement is not given to you in the exam and this question comes up, majority of people will make this mistake. Majority of people, and I can just write this out, because while attempting this question myself, I made several mistakes, and then I had to figure out why I was making that mistake. And this single mistake can be mitigated if you understand the fact that has been written in this question. So if in exam this statement which they have written currently in this question, if the statement is not given, you will make a mistake. So please be careful regarding this, right? So the statement that they have written alongside in part A, which is find stationary point of fx comma y. Now the statement is remember, and this is given in the question, remember that y square to the power 1 by 2 is equal to mod of y. I hope you guys get this statement. I'll be explaining this later on, right? So this is our question. So this is our question. 3x square plus y square. This is x square. 3x square plus y square to the power 3 by 2 minus 4x square plus y square to the power half plus y. Let me just increase the size of yeah. So find the stationary points of f, and remember that y square to the power half is equal to mod of y. Now let me just explain this statement quickly, right? So root of 25 is 5. Root of 25 is 5. Right, root of 25 is always equal to 5 because root can only take positive values. So what we mean is that this will always be equal to 5 plus 5, right? Because root can never take negative values. Root can never take negative values. So this will always be equal to 5, never negative 5. But if it is written like x square is equal to 25, then I can say that x is equal to plus minus 5, because this is an equation. X is a variable. We don't know the exact value of the expression or the variable, right? That is why we say x square is equal to 25 means that x is equal to plus minus 5. But when we say root 25 is equal to 5, this is because we know that in a root we always take positive values. So the domain for any x, so any x, for any x, if this is a function given to us, fx is equal to root x, so the domain for this is x is greater than equal to 0. This means that the root can only take positive values. So there is no question of negative 5 even entering that root, right? But when we talk about an equation which is a variable, here we can say that x can be positive or negative 5 because x is a variable. We don't know for sure what is the value of x, right? So what this statement means is that y square, the root of y square is equal to mod of y, because y can be negative or y can be positive, but so y can be greater than 0 or y can be negative. But when we put a mod, we always ensure that root of y square will always be equal to positive. So root of y is always positive. Whether y is positive or y is negative, root of y is always positive, right? So if I say that y is greater than 0, then y square, the root of y square will be mod of y, which will be equal to y. But if y is negative 0, I'll be saying that the root of y square is mod of y, which means that this is equal to negative y, right? This is a very important statement. I'll show you how we'll be applying this, right? But just remember this. I'll be just drawing a box here. Just remember this. Right. I hope you guys can see. So if I just draw a box, here. So this is the box that we'll be referring to, right? So this is y. So sorry for my handwriting. Right here. So let's just move now. So this box is our reference point. Now we'll be solving for the stationary points. So the function given to us was fx comma y. The function given to us was this. So let's just find the stationary points now. We'll be treating y as a constant. Why? Because we are finding the partial derivative with respect to x. Oh, I've missed a term here. So this 2 and 2 gets cancelled, right? So this 2 and this 2 gets cancelled. So I'll be just striking these two out, right? So I'll be left with 9. 9x x square plus y square to the power half minus 2 times x square plus y square to the power minus half into 2x plus 0, right? This is after finding the partial derivative. So this term is 9x x square plus y square to the power half minus 4x x square plus y square to the power minus half plus 0. And now I'll be equating this. Now let me just remove 0 here. Now I'll be equating this to 0 for finding the stationary points. So what will this give me? This will give me 9x x square plus y square to the power half minus 4x divided by x square plus y square to the power 1 by 2 is equal to 0. So this will give me 9x and x square plus y. I'll be taking the LCM. This will give me x square plus y square to the power, half and half gets added, 1 minus 4x divided by x square plus y square to the power half, and this is equal to 0. This was f of x. F of x, we are equating it to 0 for finding the stationary points. So ultimately this will give me, if I just take x and x common, this will give me 9x square plus y square minus 4 and this will give me divided by x square plus y square to the power half. This is equal to 0. So I can say that from the numerator I can say that x square plus y square into 9 minus 4 is equal to 0, or I can say that x is equal to 0. So these can be my two terms. This is one of my expressions, and or I can say that I shouldn't be using or here. Right? So x square plus y square is equal to 4 by 9 and x is equal to 0. These two terms I'm able to get from my by equating my first partial derivative with respect to x of my function, right? Now I'll be finding the partial derivative with respect to y. So again I'll copy my function. Again I'll copy my function. Again I'll copy my function. So now finding f of y. Now the same process, treating x as a constant. This will give me 9 by 2 x square plus y square to the power half, 3 by 2 minus 1, and 2y, 2 and 2 gets cancelled, minus 4 by 2 x square plus y square. Now 1 by 2 minus 1 will give me minus half, so minus half, and 2y will come. Now 1, because now x is a constant in this expression, so 1 will come. Now I can say that f of y is equal to 9 x square plus y square to the power half, 9y, minus 2 and 2 gets cancelled, minus 4y x square plus y square to the power minus half plus 1, and I'll be equating this to 0. Now I can say that 9y x square plus y square half minus 4y x square plus y square half plus 1 equals to 0. Now I'll be taking the LCM. I've equated the partial derivative to 0 here, and now I'm taking the LCM. So this will give me 9y x square plus y square minus 4y plus x square plus y square to the power half, which is equal to 0, and the denominator I'll be having now so this is our expression. This is my expression after equating the partial derivative of y with this to 0, right? Now I already have two expressions that I found out from my previous equation when I equated my partial derivative with respect to x to 0, right? So what these two expressions were, this x square plus y square is equal to 4 by 9 and x is equal to 0. So now I'll be creating two cases. The first case will be where x square plus y square is equal to 4 by 9. So case 1 will be case 1 x square plus y square is equal to 4 by 9. Now let's just put x square plus y square in this expression, 9y, and this will be 4 by 9 minus 4y plus 4 by 9 to the power 1 by 2. Dividing this whole expression by 4 by 9 to the power 1 by 2, and this should be equal to 0, right? So 9 and 9 goes away. Wait. This is 9. So if I just write the numerator again, I'll be left with 4. 9 and 9 goes away. This 9 and this 9 goes away. So I'll be left with 4y minus 4y plus, now the root of 4 by 9 is 2 by 3. So 2 by 3. 4y and 4y goes away, so I'll be left with, this implies that, and this should be equal to 0, so this implies that 1, this implies that 2 by 3 upon 2 by 3 is equal to 0, which implies that 1 is equal to 0, but this is not possible. Hence x square plus y square, x square plus y square is equal to 4 by 9 is rejected. We are rejecting this case because 1 cannot be equal to 0. Now moving on, our case 2 says that x is equal to 0. So now I'll be putting this here. So if I just so if I just put in x as 0, so 9y 0 plus y square minus 4y plus x square plus 0 plus y square, 0 plus y square to the power half divided by 0 plus y square to the power half, and this is equal to 9y 9y cube 9y cube minus 4y plus y, the root of y square is y, so this is also y, so my expression will be, and this should be equal to 0, this is equal to 0, right? This is equal to 0, so my expression will be, if I just take y common, y and y common, I'll be left with 9y square minus 4 plus 1, which is actually 3, so I can write this as 3, so this will be 3 minus 3 minus 3, right? And y, this should be equal to 0, so y and y goes away. I'll be left with 9y square minus 3, which is equal to 0, so y square is equal to 3 by 9, which means that y is equal to plus minus, so this is 1 by 3, right? Plus minus 1 by 3 root of 1 by 3, right? Now let's move on to part B. Or have I made some mistake? I have made one big blunder that we discussed in the start of the video, right? So the blunder is that y square, the root of y square is equal to mod of y, is equal to mod of y. I was intentionally doing all of this so that when you are seeing the video, and if by any chance you miss out or are not able to see the mistake, I can come back and again repeatedly move your attention to this fact that don't miss this out. If you miss this out, then you will be in big trouble and your answer will come out to be completely wrong, because I have made this mistake again and again. That is why I'm emphasizing on this fact that don't commit this error. Now let me make this as sub case A. This is as, let me just move this down. So all this that we did, this is just sub case. This is a sub case. Oh, I've come. So this whole thing is case 2a, where my y square to the power half is equal to mod of y, and I am taking y as greater than 0. Therefore my mod of y will become y, right? Otherwise, if my y was negative, I am assuming that my y is greater than 0. Let me write this more clearly so that you guys understand. Here I am assuming that my y is greater than 0. Let me just cut this part out. Here I am assuming that y is greater than 0. Therefore, the root of y square will be mod of y, and mod of y will give me y, because y is positive. So there is no need to attach a negative sign outside. Y is greater than 0. This is my case A of my case 2. So sub case. This is a sub case, right? 2A. Now moving on to 2B. Case 2B says that case 2B. Now here my y is negative. So here you can see that I can reject this value, right? So y, after doing all of this, the whole expression, when I computed y as greater than 0 and I substituted in the expression, the value that came out to be was x is equal to 0, which I substituted initially, and y is equal to plus minus 1 by the root of 1 by 3, right? But now I'll be rejecting the value of y is equal to minus root 1 by 3. Why? Because y is greater than 0. I have assumed that in the first place. So I'll be rejecting this value. So here the point that I'll be left with is y is equal to positive 1 by 3 to the power half, reject y is equal to minus 1 by root 3. Reject this value. Reject this value. Accept this. Accept this. Right? Hmm. So now let's just move on and solve case 2b. I'll be moving on. So case 2b now says that case 2b. So I'll be solving here. So case 2b. Here now x is 0, but my y is less than 0. Therefore the root of y square is mod of y, and now y is negative, and mod of y ensures that the value will always be positive. So I'll be introducing a negative sign outside of y. This will become negative y, right? I mean, you guys might be more intelligent than me and you won't be committing this error, but I am again and again emphasizing on this fact because I made this error a lot many times while solving this particular question, right? And here they have actually given us the fact that the the root of y square is mod of y, right? Sometimes we tend to forget this fact, and I, being a bigger fool, even after they have written this, I have genuinely made this mistake even after reading this fact. That's why I'm emphasizing it again and again on this fact, right? So now, yeah, let me just copy this expression once. This was our expression. Or this was our expression. Case 2. So this was my expression. After substituting x equals to 0, this was the expression that I was left with. So after substituting x is equal to 0, this was the expression that we were left with. Now if I just write this is equal to 9y square, so this will become 9y cube. This is 9y cube minus 4y plus, now the root of y square is mod of y divided by again mod of y. Now we know that y is negative, y is less than 0, therefore mod of y will be negative y. To ensure that it becomes positive, so 9y cube minus 4y minus y divided by minus y, and this will be equated to 0. So now I'll be left with 9y cube minus 5y minus y, which is equal to 0. This is equal to f of y, so this will give me, if I just take y common, this will give me 9y square minus 5 negative y and y gets cancelled, this will be equal to 0. So I'll be left with 5. If I just take negative sign in the numerator, so 5 minus 9y square equals to 0, so 5 is equal to 9y square. So I'll be left with y square equals to 5 upon 9, which gives me plus minus root 5 upon 3. Plus minus root 5 upon 3. Now I'll be rejecting one value. Why? Because y so I'll be rejecting y is equal to plus root 5 by 3 is rejected because our assumption was that y is less than 0. So the only value possible here is x is equal to 0 and y is equal to negative root 5 upon 3. So now the two stationary values that I have is x comma y, x star comma y star is equal to 0 comma, so this was 0 comma this was 0 comma 1 by 3 to the power 1 by 2, or 1 upon or root 1 upon 3, right? So this was our one of stationary points, and the second stationary point that we have is x comma y star star is 0 comma negative root 5 upon 3. These are my two stationary points. These are my two stationary points. Right? These are my two stationary points. Now let's just solve part B. What does part B tell us or asks from us? Part B says that let s is equal to x comma y, x is greater than equal to 0 and x square plus y square less than equal to 1. So they have given us a set. Explain why f must attain maximum and minimum over s and find the corresponding points. Now s is x square plus y square less than equal to 1 and s is and x is greater than equal to 0. I'll be writing s, but first of all let us recall the first video that I discussed with you was on extreme value theorem, and I explained you how extreme value theorem can be applied, and also I discussed one or two theorems of extreme value theorem, right? So whenever we have a set which is closed and bounded, we can apply extreme value theorem. And extreme value theorem, what does extreme value theorem says? That any continuous function, when it is defined over a closed and bounded interval, then then the function will always be attaining a maximum or a minimum, a maximum and a minimum over the interval which is closed and bounded. So if I just read out the exact theorem again, if f is a continuous function over a closed bounded set in R, then there exists both a maximum and a minimum, right? So we have a maximum and a minimum whenever our set over which our continuous function is defined is closed and bounded. So now let me write the set S. Let S is equal to x comma y, x is greater than equal to 0 and x square plus y square less than equal to 1. Now they asked us explain why f must attain a maximum and a minimum over s and find the corresponding points. So this is proven already through EVT. Whenever we have a closed and whenever we have a function, f is a continuous function defined over s which is closed and bounded. S is closed and bounded. So f is a continuous function which is defined over s which is closed and bounded. Hence f will attain a max and a min over s, right? So now let's just find. So the function given to us is f of x comma y. The function which was given to us initially was 3x square plus y square to the power 3 by 2 minus 4 x square plus y square to the power 1 by 2 plus y, right? This was the function that was given to me. Now can I just substitute the value of x square plus y square equal to 1? So the constraint that is given to me is x square plus y square equal to 1 and x is greater than equal to 0, right? This is the constraint given to me. So I'll be just substituting this expression. Actually the constraint is given to me less than equal to 1, but we have already taken care of the interior points. This is the constraint given to us. So root 1 upon 3 is less than 1, right? So y is less than y. If I just write this shows that this constraint x square plus y square less than equal to 1 is actually a circle. So this shows us that x lies between -1 and 1, y lies between -1 and 1. This additional thing, additional constraint shows us that x is greater than equal to 0, shows us that x lies between, finally after we take this also in account, we are left with x is always greater than equal to 0 and less than equal to 1, right? And y lies between -1 and +1. These are my two constraints. So the point that we found, the points that we found were x equals to 0, y equals to 1 upon root 1 upon 3, and root 1 upon 3 lies between minus 1 and 1. Yes. Now the second expression that we found was negative 5 upon 3, root negative 5 upon 3. So the other expression that we found was wait a minute. I've made a mistake here. This should be root of 5 upon 3. Y is equal to root of 5 upon 3. Root of 5 upon 3. So y should be negative root 5 upon 3, right? Yeah, so I've corrected myself now. I'm so sorry. Now let us move on. This is absolutely clear. Now x is equal to 0 again in the second point, and y was negative root 5 upon 3. Right. So negative root 5 upon 3. Negative root 5 upon 3 is negative root 5 upon 3. So we know that root 4 is equal to 2 and root 9 is equal to 3. So basically root 5 will lie between 2 and 3, and negative root 5 will lie between minus 2 and minus 3. And if I just divide this whole expression by 3, this will give me right. So we are well within our constraint, right? Y was lying between negative 1 and positive 1, and here also we can say that negative root 5 upon 3 is lying between negative 1 and positive 1, right? Because it's less than minus 2 by 3 but greater than minus 1, right? So both of these points are interior stationary points. Both of these points that we got after finding the partial derivatives are our interior stationary points. Now we only have to take care about the constraint. So the constraint is x square plus y square equal to 1. X square plus y square equal to 1 is our constraint, along with and x is greater than equal to 0, right? So this is our constraint, and now I can substitute this constraint directly into my function. So the function given to me was this. Let me just copy. I guess this video is longer than I imagined, but yeah, this question is one of the finest questions of this exercise. It has a lot of things, and it's always nice to solve this question again and again. So now I can just substitute this expression, x square plus y square equals to 1. If I just substitute x square plus y square equal to 1, I'll be left with 1 to the power 3 by 2 minus 4 into 1 to the power 1 by 2 plus y. So I'll be left with 3 minus 4 plus y, which will be y minus 1. So f of x comma y will be y minus 1. And can I write fx comma y now as g of y, because fx comma y has turned into a single variable function. So I can write it as y minus 1. Now I'll be solving y minus 1. So g of y is y minus 1. G dash y is 1. So g of y is an increasing function. So the least value that g of y can have, g of y is equal to 1, y minus 1 can have is when y is the lowest possible value. So y was lying between 1 and minus 1. So the lowest possible value that y will have is negative 1. So g of negative 1 minus 1 minus 2. So this is the least possible value, and the highest possible value can be g of 1, which is 1 minus 1, which is equal to 0. Now when y is equal to negative 1, when y is equal to negative 1, when y is equal to negative 1, x square plus y square equals to 1 tells us that x is equal to 0. And when y is equal to, and when y is equal to 1, x square plus y square, x square plus y square, x square plus y square tells us that x square plus y square equals to 1 tells us that x is equal to x is again equal to 0, right? So the 2 points that I have is, so the 2 points that I can write from this is, 2 points that I can write from this is 0 comma negative 1 and 0 comma positive 1. 0 comma negative 1 and 0 comma positive 1. So now let me just consolidate what all we have done so far and just write our final answer. So now we have taken care of the constraint, we have taken care of the boundary condition, everything has been done. Now we just need to compute the final values and write and declare which is the maximum value or which is the minimum value, right? So the points that I have is, first point is 0 comma 1 by 3 to the power half, second point is 0 comma minus root 5 upon 3, third point is 0 comma 1, fourth point is 0 comma minus 1. So I don't even have space left to compute the final values, but if I just zoom this, I'll be left with a lot of space. So f of 0 comma 1 by 3 to the power half, if I just substitute this in my expression, I'll be left with 3 and this becomes 0, this becomes 1 by 3 to the power 1 by 1 by 3 to the power 3 by 2 minus 4 and 0 plus 1 by 3 to the power 1 by 2 plus root 1 by 3. I'll be writing this as root 1 by 3. So this will give me ultimately this will give me 3 and 3 by 2 minus 4 into 1 by 2. So this will become 3 and 1 minus 1 by 2. So this will become this, and this goes away. So I'll be left with f of 0 comma 1 by root 3 is equal to minus 4 upon root 3. Now let's just find the second value at point 0 comma negative root 5 upon 3. So again, if I just substitute 0, 3, 0 plus, now the square of this will be 5 upon 3, this will be 5 upon 3, 5 upon 9 to the power 3 by 2 minus 4, 0 plus 5 upon 9 to the power half plus negative root 5 upon 3, right? So this will be 5 to the power 3 by 2, and this will be, so the square root of 9 is 3 and cube of 3, so 3 cube, and this will give me 3 square, and this will become again root 5 upon 3. So hmm, 5 into 5 plus 1 plus 1 by 2 is 3 by 2, right? Yeah, 1.5. Yeah. So we'll be left with this only. Ultimately my value will be ultimately my value will be ultimately my value will be I might have made some kind of calculation mistake. I have that feeling. Anyways, we'll check at the end. Alright. Minus 2 by 9 upon minus 2 by 9 to 5 to the power 3 by 2. So we have found this value. Now we have to just find 0 comma 1 and 0 comma minus 1. So if I just substitute 0 and 1, 0 and 1, I'll be left with 0 and 1. So this will give me 3 and 3x square. So 0 plus y square is 1. 1 to the power 3 by 2 minus 4 into 0 plus 1 and then the root and then 1 again. So if I just compute this now, 3 minus 4 plus 1, which is minus 1 and 1, minus 1 plus 1, 0. And now the final value, f of 0 comma minus 1. So this will be 3 0 plus again 1 to the power 3 by 2 minus 4 0 plus again 1, yes, to the power 1 by 2, then minus 1. So this will be 3 minus 4 minus 1, which is minus 2. Now we need to just compare the values and see. So by far this is the maximum value. Why? Because this is the only value which is not negative. So this was also negative, this was also negative, and this is also negative, this is also negative, and this is also negative. So only this value is equal to 0, neither positive neither negative. So this is our maximum value, max at 0 comma 1. And if you see, this is equal to the above expression, this is equal to 4 divided by 1.73. 4 divided by 1.73, negative 4 divided by 1.73, slightly greater than negative 2. Oh, slightly less than negative 2. Slightly negative, less than negative 2. So this expression minus 4 and the value of root 3 is 1.73. But I'll be taking it as 2. So the highest possible value, if I just round it off 1.73, I'm rounding it off to 2. So if I just take, so this will be negative 2. So minus 4 by root 3 will be just greater than negative 2. Just greater than negative 2. Right? Just greater than negative 2. Wait a minute. Sorry. Just slightly less than negative 2. So sorry. Slightly negative less than 2. The denominator is a smaller number, right? So this is slightly less than negative 2. Slightly less than negative 2. Now this expression, 5 to the power 3 is equal to 125, and 125, the root of 125, so 121. Let us take this as 121, and the root of 121 is 11. So minus 22 by 9. Minus 22 by 9 is greater than is less than negative is less than 3 is less than negative 3, but it's greater than 2. It's greater than 2. No, is it greater than 2? 22 by 9. 22 by 9 is greater than 2. 18 by 9, right? So negative 22 by 9 is again less than negative 2. And this is negative 2. So this is automatically rejected. This cannot be our min. This cannot be our min because this is obviously equal to negative 2, and we have values here which are less than negative 2 also. So now we need to find the exact values of 4 upon root 3 and minus 2 into 5, 3 by 2, right? Now we need a calculator to find this the exact value. I would need a calculator. Let me just check on the internet and see what's the exact value, and I'll just write the final answer then. So I feel that this will be the least value, 0 comma root 5 by 3. So let me just write 5 root 125 divided by 9 and multiplied by 2. So this is equal to minus 2.48. This is equal to approximately minus 2.48. This is slightly equal to minus 2.48. This is equal to negative 2.48. I hope you guys can see my screen. Negative 2.48. And this value root so this value 4 upon root 3, 4 divided by 1.73, 2.31. yes, so this value is equal to 2.31. yeah, so this value is approximately equal to, this value is equal to negative 2.31, and this value is equal to minus 2.48. Therefore our max exists at 0 comma 1, where f of 0 comma 1 is equal to 2, and min at 0 comma negative 5 root 5 upon 3, where my f of 0 comma negative root 5 upon 3 gives me negative 2.48. Now we can check the answer, but I don't have my battery left in my iPad. I would have to quickly check the answer and present the screen. Can you see my screen? No, I don't think you guys can see my screen. Yeah. Let me just quickly present my screen. Window capture. Even question. So let's just see the answer. I hope you guys can see the answer. We can include, see, the stationary points are the stationary point that we got were, just give me a minute, let me just adjust my screen. Yeah. So it's saying that right, so it's saying that my max occurs at, my max is at, wait, my stationary points are 0 comma 1 upon root 3 and 0 comma negative root 5 upon 3, right? Now part B says that my maximum value is 0 at 0 comma 1 and my smallest value is minus 10 root 5 upon 9 at this 0 comma root 5 upon 3. So minus 10 root 5 upon 9 is, yeah, so we had let me just check once more. So we had, wait a minute, yeah, so we had minus 2 and 5 to the power 3 by 2. So if I just take out 5 square out, so I'll be left with negative 10 upon 9 into root 5. Yeah, so we are clearly, what we have done is correct. Where is my lonely screen? My lonely and my only screen. Oh my god. So I'll be attaching the working and you guys can see what we have done. So if you want to check, you can also try and find the exact value of negative 10 into root 5 upon 3, right, or 9, I don't know, but what we have done is absolutely correct. So thank you for watching this video, and please do put in a comment and do subscribe my channel. It pushes me to make more and more videos, bring more and more concepts, and try and solve more and more questions. Solving more questions helps me a lot personally and increases my knowledge, whilst sharing the knowledge with you solidifies that knowledge for me also. So it is a mutual relationship. The more you watch my videos, the more my knowledge increases, the more your knowledge expands, and it's a win-win situation for both of us. So please do subscribe to my channel, put in a comment, and share the video with your friends so that more and more people can watch this and I can keep on coming with more and more videos. Thank you, and I see you in the next video. Bye bye.